Hello everyone, this is Alex Itawal. I'm a final year student of Faculty of Engineering and Technology, University of Lucknow, Department of Civil Engineering. Today, I am going to give a seminar presentation on cross-laminated timber construction. Moving on to the next slide, we have table of contents. We will be discussing introduction, advantages of CLT, sustainability, application in construction of CLT buildings, iconic CLT building, structural performance, environmental impact, challenges and mitigations, case studies, future trends, and conclusions. Introduction. Cross-laminated timber (CLT) is an innovative building material formed by layering and bonding perpendicular layers of dimensional lumber which enhances structural stability, creating panels with exceptional strength and load-bearing capabilities. CLT offers sustainability benefits due to its renewable sources and carbon sequestration properties. Its fabricated nature facilitates efficient and eco-friendly building practices, making CLT a prominent choice in modern construction for both residential and commercial projects. In the figure number 1, cross-layering of laminated timber can be shown. In the figure number 2, world's biggest CLT building can be seen, which we will be discussing in the further slides. Advantages. Prefabricated CLT panels allow for faster on-site construction, reducing overall project timelines. Accelerated construction schedules can lead to cost savings and quicker occupancy of buildings. Despite its lightweight nature, CLT exhibits impressive structural strength. While initial cost may vary, the overall cost efficiency of CLT construction is notable, especially considering reduced labor and construction time. Long-term economic benefits may outweigh initial investment costs. CLT offers architects and designers increased flexibility in design, enabling the creation of unique and innovative structures. Its ability to span long distances without the need for additional support enhances design possibilities, provides good thermal insulation contributing to energy efficient buildings, supports sustainable forestry practices, carbon sequestration, contributing to a positive environment footprint. Sustainability. Cross-laminated timber is at the forefront of sustainable building practices as it originates from well-managed forests. The production of CLT involves a significantly lower carbon footprint compared to traditional construction materials such as concrete and steel. The manufacturing process requires less energy, emits fewer greenhouse gases, and utilizes renewable resources. At the end of a building's life, CLT can be recycled, repurposed, or used as a biomass for energy production. The timber used in CLT panels requires less energy to process compared to the energy-intensive production of concrete and steel. Additionally, the off-site prefabrication of CLT panels further reduces energy consumption and waste during construction, enhancing the overall stability of the building process. Cross-laminated timber construction not only minimizes the environmental impact through sustainable forest management, but also actively contributes to global sustainability goals by offering a lower carbon alternative to traditional construction materials. Applications of cross-laminated timber construction, single-family and multi-family homes. CLT is increasingly used for residential homes due to its structural integrity, design flexibility, and quick assembly. CLT supports the construction of mid-rise and high-rise apartment buildings, providing a sustainable alternative to traditional materials. Offices and retail spaces. CLT is employed in office buildings, allowing for open floor panels and aesthetically pleasing designs. Its adaptability makes CLT suitable for creating unique and inviting retail environments. Schools and universities. CLT is used in educational buildings for its speed of construction and ability to create inspiring, modern spaces conducive to learning. Adaptive reuse. CLT is used in the renovation of existing structures, providing a sustainable solution for updating and repurposing buildings. Exhibition halls and pavilions. CLT is employed for temporary structures due to its ease of assembly and disassembly, allowing for sustainable temporary event spaces. Warehouses and factories. CLT strength and quick construction make it suitable for industrial structures, providing efficient and durable spaces for various industries. In this slide, we can see some iconic CLT buildings. In the figure number 3, we have the Tallwood residence at the University of British Columbia in Vancouver, which is completed in the summer of 2017. This building stands 53-meter high, easily making it the tallest CLT building constructed till date. Figure number 4, we can see the War Thistleton, which is designed by British architect. The 121 unit residential plywood building is not only one of the tallest timber buildings but ever created, but also the largest CLT building constructed to date. Now moving on to the next slide, we have the structural performance. The structural performance of CLT in construction is marked by its strength, versatility and adaptability, making it a reliable choice for a wide range of building applications. The material not only meets but often surpasses the structural requirements, contributing to the growing adoption of CLT in the construction industry. CLT has proven to be a robust and reliable material, offering impressive structural performance across a range of building types. Following are some aspects highlighting the structural prowess of CLT in construction. First, we have the load bearing capacity. Now, vertical loads. CLT exhibits exceptional vertical load bearing capacity, supporting the weight of multiple floors in buildings. Horizontal loads. CLT panels can also effectively resist horizontal loads, contributing to the overall stability of structures. Second, long spans and design flexibility. Large clear spans. Now, CLT strength allows for the creation of large open spaces without the need of extensive supporting columns, providing design flexibility. Architectural freedom. Architects can leverage CLT to design innovative and visually appealing structures, including curved or cantilevered elements. Third, we have seismic resilience. Energy dissipation. CLT's layered structure allows for the dissipation of seismic energy, contributing to the overall seismic resilience of the buildings. Performance in seismic zones. CLT has demonstrated effectiveness in seismic zones, providing a viable alternative to traditional construction materials. Moving on to the next slide, we have the environmental impacts of cross-laminated timber construction. Cross-laminated timber construction significantly mitigates environmental impact compared to traditional building materials like concrete and steel. Here is an overview of how CLT contributes to a more sustainable and eco-friendly construction industry. First, carbon sequestration. Positive carbon footprint. Wood used in CLT actively sequesters carbon during its growth phase. This carbon remains stored in the CLT panels, acting as a carbon sink even after the harvesting and processing. Net carbon reduction. The use of CLT in construction results in a net reduction of atmospheric carbon dioxide, helping combat climate change. Second, renewable resource. Sustainable forestry. CLT is derived from sustainably managed forests where trees are harvested responsibly. This ensures a continuous cycle of planting and harvesting, maintaining the health of forest ecosystems. Forest certification. Many CLT manufacturers adhere to forest certification standards such as FSC or PEFC, ensuring responsible and ethical sourcing practices. Third, lower embodied energy, reducing energy consumption. The production of CLT requires very less energy compared to traditional materials like concrete and steel. This reduction in embodied energy contributes to overall energy efficiency in construction. Resource efficiency. CLT panels are manufactured off-site with precision, minimizing waste and optimizing the use of resources during the construction process. Fourth, reduced greenhouse gas emission, lower emissions. The manufacturing of CLT generates fewer greenhouse gas emissions compared to the production of concrete and steel. This reduction in emissions aligns with the global efforts to reduce the carbon footprint of construction. Recyclability. Recycling. At the end of a building's life, CLT can be recycled or repurposed, contributing to a circular economy. Minimal construction waste. Precision manufacturing of CLT offsite, minimizing offsite, on-site waste during construction, reducing the overall environmental impact. Sixth, biodiversity and ecosystem preservation. Responsible forest management. The demand for CLT supports responsible forest management practices, preserving biodiversity and ecosystem, forest health. Sustainable forestry ensures the long-term health and vitality of forested areas. Seventh, air and water quality. Cleaner manufacturing processes. The production of CLT involves cleaner manufacturing processes, contributing to a better air quality compared to the emissions associated with traditional building materials. Reduced water use. CLT manufacturing typically requires less water compared to processes involved in producing concrete and steel. Eighth, energy efficient buildings. Thermal performance and noise. CLT provides excellent thermal insulation, contributing to energy efficient buildings and reducing the overall energy consumption required for heating and cooling. The construction process makes very less sound compared to national conventional construction. In this slide, we will be discussing the challenges and the mitigations which come in the construction of cross-laminated timber. First, moisture sensitivity challenge. CLT is sensitive to moisture, which can lead to swelling, warping, or even decay. Mitigation, seasoning, sealing, and protective measures during construction can minimize moisture exposure. Additionally, using treated or engineered wood with enhanced moisture resistance can help address this challenge. Second, fire performance. Challenge. Although CLT has inherent fire resistance due to charring, there are concerns about fire performance during the construction and in certain applications. Mitigation. Implementing fire safety measures during construction and using additional fire retardant treatments or coatings can enhance CLT's fire performance. Cost. Challenge. Now, initial cost of for CLT can be higher than traditional construction materials, impacting the budget for some projects. But the mitigation we have increased adoption and advancements in manufacturing processes may contribute to cost reductions over time. Assessing long-term benefits such as energy efficiency and faster construction can help justify initial cost. Transportation and logistics challenge. CLT panels can be large and heavy, posing challenges for transportation and on-site logistics, especially in urban areas. Mitigation. Planning for efficient transportation, including prefabrication near the construction site and coordinating logistics, can help overcome this challenge. Fifth, code and standards compliance challenge. Building codes and standards for CLT construction may vary, and some regions may lack specific regulations. Mitigation, staying informed about local building codes, participating in code development discussions, and advocating for CLT standards can help address regulatory challenges. Sixth, skills and training challenge. Construction professionals may need specialized skills and training for working with CLT due to its unique characteristics. Mitigation. Investing in training programs, collaborating with experienced CLT manufacturers and sharing best practices within the industry can enhance the skills of construction professionals. Seventh, limited market adoption challenge. CLT is not as widely adopted as traditional materials, leading to a limited market presence. Mitigation. Industry awareness campaigns showcasing successful projects and advocating for the benefits of CLT can contribute to increased market acceptance. Eighth, perception and education challenge. There may be misconceptions or lack of awareness about CLT's properties and benefits among architects, engineers, and clients. Mitigation. Educational initiatives, case studies, and demonstration projects can help dispel myths and build confidence in CLT constructions. Now we are leading towards the end of this presentation. Now we will be discussing three case studies. Case study number one, fort building. Fort is a 10-story, 32.2 meters high residential building in Melbourne, Australia. It is the first CLT building in Australia. It was built in 2012 by Lendlease and was designed by Andrew Neeland. The building comprises 759 CLT panels of European spruce, weighing a total of 485 tons. The spruce for the CLT panels was grown and harvested in Austria. The panels were manufactured and then shipped to Australia. In comparison to a standard concrete and steel building, Fort reduces CO2 emissions by over 1451, which is 1451 tons. using timber is also estimated to save 7.7 million liters of water. Figure number 5 shows the fort building. Moving on to the next slide. Case study 2, Brock Commons Tallwood House. It is a 18-story building which is 53 meters high. It is a residential building in Vancouver, Canada. It was built in 2017. The construction started in 2015 by Fast plus Ep and was designed by Acton Austria architects. It is constructed from two concrete cores along with the CLT floor panels that are supported by glulam columns. Carbon stored in the wood is 1,753 metric tons of CO2. Avoided greenhouse gas emissions is 679 metric tons of CO2. Total potential carbon benefits we can see is 2,432 metric tons of CO2. Now figure number 6 shows the Brock Commons Tallwood House. Moving on to the next slide, we have our case study 3, which is Stathos. Stathos is a 9-story building which is 30 meters high, 98 feet high. It is a residential building in Hackney, London. It was built in 2009 by Techniker Limited and was designed by Worth Thistleton Architects. The type of timber constructed used in the construction of this building was European whitewood. The fabric of the stores over 181 tons of carbon. By not using reinforced concrete frame, 125 tons of carbon is saved from entering the atmosphere, which is equivalent to 21 years of carbon emissions from a building of this size. Figure number 7 shows Stathos. Moving on to the next slide, we have future trends of CLT buildings and CLT construction. Some countries have started to offer carbon credits for CLT projects to promote its environmental benefits. Advances in manufacturing processes may lead to more efficient and cost-effective production of CLT. Automation, precision cutting, and improvements in adhesive technologies may enhance the quality and reduce the cost of CLT panels. With an increasing focus on sustainability and carbon neutral construction, CLT's eco-friendly characteristics may become even more attractive. The construction industry is becoming more digitized, and this trend is likely to extend to CLT constructions. Building information modeling, which is BIM, and other digital tools could be used to design and plan CLT structures more effectively, improving efficiency and reducing errors. The future of sustainable buildings is here. CLT is a high performance that enables innovative designs and carbon storage. As CLT becomes more advanced and affordable, it will transform how we construct spaces for living, working, and learning. We have reached to the conclusion of our seminar. Number 1, cross laminated timber CLT is cost efficient, sustainable, and requires less labor. Number 2, CLT contributes into less noise pollution local businesses and is good for environment as it emits less carbon. Bullet number 3 says CLT is lightweight and promotes design flexibility. CLT constructed structures have demonstrated good seismic performance in various studies. CLT construction is very fast as compared to conventional construction. The last conclusion we have is CLT structures promote construction of temporary buildings. We have reached to the end of our seminar. Thank you all for going through my seminar presentation. Thank you.